Imagine standing on a beach thousands of years ago, watching the sun sink into the horizon. The world seems flat, the sky a solid dome. Ancient Egyptians describe the earth as a disk floating on water, while Norse myths tell of a ring-shaped world encircled by a serpent. Chinese traditions sometimes pictured a square earth with a round sky. Were these stories poetic metaphors or glimpses of lost knowledge? Without ships that crossed oceans or balloons that rose above the clouds, a flat plain made sense. The horizon looked like a hard line. The stars traced an arch across the dome overhead. Priests and philosophers wrapped these observations in spiritual narratives. But curiosity didn't stay still. Early thinkers began to ask, if the world is a disk, where's the edge? Does anything lie beyond? The stage was set for one of history's greatest scientific adventures, and perhaps the seeds of a cover-up were planted. Legend has it, in the ancient city of Alexandria, there lived a librarian whose curiosity would change the world forever. His name was Eratosthenes, a man of books, numbers, and bold questions. Some called him a dreamer, others a genius. But one summer solstice, a simple letter would spark a quest for truth. Was the earth flat, as many believed, or was there a hidden curve waiting to be revealed? This is the story of how myth met science and how a librarian measured the world. What if I told you that over 2,000 years ago, a librarian figured out the size of our entire planet using nothing more than a stick and a shadow? This is the story of Eratosthenes, chief librarian of the Great Library of Alexandria. In the 3rd century BC, he received a curious letter from the city of Syene, describing something remarkable. On the summer solstice, the sun shone directly down a deep well, casting no shadow whatsoever. Eratosthenes knew that on the same day in Alexandria, a stick planted in the ground definitely cast a shadow. Most people might have dismissed this as a local oddity, but this librarian saw something extraordinary. If the earth were flat, wouldn't the sun hit both cities at exactly the same angle? The fact that it didn't could only mean one thing. The earth was curved. So he measured the shadow's angle in Alexandria, about 7 degrees. He knew the distance between the cities was roughly 800 kilometers. Using simple geometry, he calculated that if 7 degrees represented 800 kilometers, then the full circle would be about 40,000 kilometers around. The actual circumference of Earth? 40,075 kilometers. He was off by less than 200 kilometers. With no satellites, no modern instruments, just observation and mathematics, this ancient librarian achieved 99.5% accuracy. But not everyone was convinced. Some skeptics questioned Eratosthenes' measurement. Could the numbers be fudged? To convince people, you need real data. So can we trust Eratosthenes? Let's try it ourselves. On the summer solstice, place sticks in Alexandria and Syene and measure the shadows at noon. The angles will match Eratosthenes' results, about 7 degrees apart. Multiply that angle by the distance, and you get Earth's circumference. It's science you can test. With 2 sticks, a sunny day, and math, the shape of our world is revealed. His experiment stands as a testament to observation, reason, and curiosity. And that's how a librarian measured the world. Look up at the night sky from different places on Earth, and the stars tell different stories. Traveling north, the North Star climbs higher above the horizon. Traveling south, it sinks and vanishes. Whole constellations, like the Southern Cross, appear in some hemispheres and never in others. Ancient mariners navigated by these changes long before maps existed. If Earth were a flat plane, the geometry of the stars would remain constant, no matter where you went. Yet they shift predictably, as if you're moving around a sphere. During lunar eclipses, Earth's shadow slides across the moon as a perfect arc. Could a flat disk cast a round shadow from every angle? Conspiracy whispers aside, the evidence is written in the night sky. Still, some say ancient astrologers hid this knowledge, fearing it would upset powerful hierarchies. By learning to read the heavens, did they expose a global truth or a cosmic deception? The stars don't lie. They've been telling us the truth about our world for millennia. In 1519, Ferdinand Magellan set out with 5 ships to find a westward route to Asia. 3 years later, his expedition, without Magellan, who died en route, returned from the east, having circled the world. Stories of falling off the edge failed to materialize. Was this an elaborate hoax orchestrated by monarchs to keep the masses ignorant? Or did those sailors simply follow Earth's curvature and prove it firsthand? In later centuries, countless explorers repeated the feat, sometimes disappearing for years, only to appear on the other side of the world. Today, commercial airlines plot great circle routes that arc across the map, but make sense on a globe. Could all airlines, ship captains, and cartographers be in on a centuries-long lie? If so, why? Perhaps the truth is simpler. The planet curves, and human curiosity has traced it. Point a camera at the night sky for hours and the stars draw circles. In the northern hemisphere, those circles pivot around Polaris. In the southern hemisphere, they spin around a different spot. The center of each star trail circle corresponds to Earth's axis pointing into space. The height of that circle above your horizon matches your latitude. Coincidence or geometry? Some say the stars are attached to a rotating dome. Others think they reveal our planet spinning like a top. If a dome were turning, would its motion vary by location? Star trails at the equator lie flat along the horizon. At the poles, they spin overhead. These patterns fit a round Earth model elegantly, but conspiratorial thinkers might wonder, could all astrophotographers be using doctored footage? When astronauts on the International Space Station film star trails encircling Earth, are we seeing reality or a CGI masterpiece? Decide for yourself as we unravel more clues. Ask a flat Earth believer and they might tell you every photo of Earth from space is faked, a Hollywood production. Yet from the first images snapped by Soviet spacecraft to Apollo's famous blue marble, photographs have shown Earth as a glowing sphere. Today, weather satellites stream live images of storm systems swirling around a curved horizon. Privately owned satellites and probes from multiple countries send back similar pictures. Images cannot all originate from a single agency with a single agenda. If these photos were doctored, thousands of engineers, scientists, and satellite operators across competing nations would have to be in on the scheme. Is such a vast conspiracy plausible? Or is it more likely that the pictures simply show Earth's true shape? As technology advanced, the number of witnesses grew. Now even amateur satellites launched by students capture the curve. In the face of so much imagery, the conspiratorial claim of a coordinated deception strains credibility. Gravity is an unseen force pulling everything toward a center of mass. On a sphere, that means down is always toward Earth's core. On a flat disk, gravity would pull you diagonally toward the center as you moved outward, making buildings lean and bridges twist, something we never observe. Architects and engineers rely on this uniform downward pull to erect skyscrapers and dams, while geodesists and space agencies count on it to place satellites into stable orbits around a central mass. Systems like GPS triangulate your position using timing signals from satellites. Their calculations assume a spherical world. If Earth were flat, its gravitational field would be inconsistent, orbits would be unstable, and global navigation would fail. The fact that rockets reach orbit, satellites stay aloft, and your phone can tell you where you are is quiet, everyday proof that Earth is a globe. In 1851, Paris visitors witnessed a heavy pendulum suspended in the Pantheon trace a slow circle on the floor. Léon Foucault's pendulum provided a simple, elegant demonstration that Earth rotates.
The pendulum swings in the same plane, but as Earth turns underneath, its path appears to rotate. At the North Pole, a pendulum would rotate once every 24 hours. At the equator, it wouldn't rotate at all.
Conspiracy-minded skeptics might wonder if the pendulum was secretly being pushed, or if the floor moved beneath it. But Foucault pendulums have been built in countless museums and universities worldwide, all showing the same effect. Observing them, you can watch the planet turn. Combined with star trails and satellites, pendulums form a trio of independent evidence for a rotating globe. If such demonstrations were tricks, why would hundreds of institutions contain them? Sometimes the simplest experiment is the hardest to refute. Everyone knows that when it's midday in one city, it's midnight somewhere else. Time zones divide the world because the planet rotates. Skeptics might ask, could a flat Earth with a small spotlight-like sun explain this? Imagine a lamp suspended above a table. Parts of the table would be lit, while others remain in darkness. But watch how sunrise creeps gradually around the world rather than switching on and off. The sun's path crosses the sky, not the overhead dome. Earth's tilt relative to its orbit creates seasons. When the northern hemisphere leans toward the sun, it experiences longer days and warmer weather, while the south leans away. At the poles, the sun doesn't set for weeks in summer and doesn't rise in winter. Video footage from Antarctica shows the sun circling the horizon continuously, contrary to a spotlight model. Either thousands of researchers and tourists are part of an elaborate ruse, or Earth is a tilted sphere basking in sunlight. When an earthquake shakes the ground, waves travel through the planet. Seismologists listen to these waves. Some move through solids, others cannot pass through liquids. By mapping where waves are received and how they change, scientists infer that Earth has layers: a crust, mantle, liquid outer core, and solid inner core. Flat Earth adherents sometimes claim seismic data are fake or misinterpreted to support the globe theory. But recorded wave patterns match what a spherical planet with a metal core would produce. Additionally, variations in Earth's gravitational field, measured by satellites, correspond to mountains, trenches, and mantle convection, all consistent with a globe. Could geophysicists worldwide be fabricating data? Seismic stations are operated by universities, governments, and private groups across continents. Coordinating a deception would be monumental. The shaking of Earth itself whispers its shape if one cares to listen. You don't need laboratories to test the planet. Watch a ship sail away. First, its hull disappears, then its mast, exactly what you'd expect if it dips below a curve. Climb a hill, a skyscraper, and see how your horizon expands. The higher you go, the farther you can see. On a calm day, take binoculars to a lake and observe that objects partially vanish when far away. Some flat Earth enthusiasts perform canal or laser experiments to prove flatness, but often ignore atmospheric refraction or measurement error. When corrected, the results align with a curved surface. Even consumer drones ascending a few hundred meters capture a slight curvature. Are your eyes deceiving you? Could every horizon be a hologram? The simplest explanation, Occam's razor might suggest, is that Earth is curved. Yet, acknowledging that you can test it yourself adds to the intrigue. What else can we discover with simple tools? You pull out your phone, open a map app, and instantly know your location. How? GPS satellites orbit Earth and transmit signals that your phone triangulates. The math used by GPS assumes a spherical Earth. Pilots chart flight paths using great circles, not straight lines on flat maps, to save fuel. Undersea cables linking continents curve along the seabed, reflecting the sphere's shape. Meteorologists predict storms using global circulation models on a rotating sphere. Their predictions wouldn't work on a flat plane. Engineers design bridges, tunnels, and pipelines accounting for curvature. If Earth were flat, these systems would accumulate errors that would soon become obvious. A conspiratorial mind might argue that all engineers and scientists collaborate on an elaborate deception. But the variety of industries, aviation, shipping, telecommunications, makes that unlikely. Our everyday devices and infrastructure silently confirm the globe. Ever notice how hurricanes in the north always spin counterclockwise while down south they spin clockwise? It's not some mysterious force at work. It's the Coriolis effect. Here's the deal. As our planet spins, moving air and water get deflected. Think of it like this. If you're on a spinning merry-go-round, Trying to throw a ball straight, it curves to the side. Same principle, but with Earth's rotation affecting massive air masses. This invisible force shapes everything. Trade winds, ocean currents, even jet streams. Without it, our entire climate system would be completely different. Now, some flat Earth folks dismiss this, claiming local factors drive all wind patterns. But here's the thing. You can demonstrate this yourself. Spin a dish of water and watch the spiral currents form. No computer tricks needed. And those satellite images of spinning storms? When hurricanes make landfall, you can feel those rotating winds firsthand. They're as real as the ground beneath your feet. The Coriolis effect is nature's signature on a spinning planet. Every hurricane, every trade wind, every ocean gyre tells the same story. We're living on a world in motion. After venturing through ancient myths, shadow experiments, star patterns, circumnavigation, space photography, gravity, pendulums, time zones, earthquakes, horizon observations, technological applications, and weather dynamics, the evidence points overwhelmingly toward a round, spinning Earth. Could all these independent phenomena across history, culture, and science be orchestrated to mislead? A conspiracy of such scale would require millions of people in thousands of disciplines, coordinate flawlessly for centuries. It's far more plausible that Earth is a globe and that occasional conspiratorial whispers reflect human fascination with hidden truths. Still, mystery fuels curiosity, and curiosity drives discovery. Before closing the case, we'll explore the other side of the debate. Why do some insist Earth is flat? What evidence do they present, and how persuasive is it? Strap in as we plunge into the flat Earth universe, where the hints of conspiracy become the central narrative. Long before satellites and international flights, people accepted a flat Earth as common sense. Seas looked level and lands appeared boundless. As science advanced, spherical models gained acceptance. But the flat world never disappeared. During the 19th century, when institutions like universities and governments were gaining authority, certain thinkers rebelled. They suspected elites of controlling knowledge and hiding truths. In a time of industrial upheaval, distrust of authority was fertile ground for alternative cosmologies. Could it be that our ancestors knew something we've forgotten? Some flat Earth adherents argue that ancient myths were right all along, and that modern science stripped away ancient wisdom. Revisiting these stories sparks the imagination. What if the world really is a plane with a dome above and unknown lands beyond? Such ideas appeal to those who believe secrets lurk just over the horizon. Picture this. A Victorian gentleman in a top hat standing by a canal, convincing crowds that everything they knew about Earth was a lie. Meet Samuel Rowbotham, the unlikely prophet of the modern flat Earth movement. Born in 1816, he was a self-taught thinker, fascinated by science but skeptical of authority. Operating under the pseudonym Parallax, this self-proclaimed scientist toured Britain in the 1800s, preaching what he called Zetetic astronomy. Rowbotham offered simple answers in a confusing world. His radical claim? Earth isn't a spinning globe, but a flat circular plane with the North Pole at its center and a towering ice wall around the edges. The Bedford level experiment. Rowbotham claimed all markers stayed visible, proving the Earth was flat. His demonstrations drew crowds and headlines. To his audiences, this was smoking gun evidence of a planetary cover-up. Inspired by Rowbotham, followers formed Zetetic societies to spread his ideas. But here's what made Rowbotham truly dangerous. He understood his audience. Despite repeated debunkings, Rowbotham's charisma kept his movement alive. For many, it was about questioning authority. In an era when working-class people felt excluded from academic science, Rowbotham positioned himself as their champion. So, was Rowbotham a misunderstood genius or a clever manipulator? Facts rarely defeat a compelling narrative, especially when delivered by a charismatic speaker. Today's Flat Earth movement still quotes Rowbotham's writings. For some, it's about seeking truth. For others, it's about belonging to a group
that questions the status quo. So was he a genuine truth seeker, or simply a master showman who discovered that sensational claims attract attention? What do you think?
In the 1990s, you could count flat Earth believers on your fingers. Today, millions watch their videos online. What changed wasn't the evidence, it was the internet. For most of the 20th century, flat Earth societies were tiny operations. Think mimeographed newsletters posted to a handful of subscribers, maybe a few dozen people worldwide sharing fringe theories through the mail. Then the internet arrived, and everything shifted. Suddenly, anyone with a camera and a theory could broadcast from their bedroom to billions. Videos questioning NASA footage or reinterpreting Bible verses through a flat Earth lens began racking up millions of views. One viral video claimed to show the edge of the world, sparking heated debates and reaction videos across YouTube. Comment sections exploded with arguments. Social media algorithms didn't care about truth, they cared about engagement. Controversial content keeps people watching, commenting, sharing. The more outrageous the claim, the further it spread. Soon, hotel conferences were drawing hundreds of attendees. Merchandise booths sold t-shirts proclaiming, "Research Flat Earth." Online forums and Facebook groups became echo chambers, where believers shared experiments and debunked critics together. At conventions, attendees swapped stories, posed for group photos, and listened to speakers challenge mainstream science. For many, this wasn't just a belief. It became an identity, a badge of honor for questioning mainstream narratives, which raises a fascinating question. Are these followers simply gullible victims, or are they tapping into legitimate concerns about institutional trust and misinformation? The movement's explosive growth reveals something profound about human psychology. Confirmation bias played a huge role. People sought out information that fit their worldview, ignoring evidence to the contrary. For some, joining the movement was about belonging, finding a tribe that made them feel seen and heard. We crave community, want to feel special, privy to secrets hidden from the masses. The internet didn't just spread flat Earth theories, it created a global tribe around them. And that's perhaps the most unsettling part. If algorithms can turn fringe newsletters into viral movements, what else might be brewing in the depths of the internet as new movements rise and fall online? One questioner in the world of misinformation decides what's true. Maybe the real question is, are we questioning enough? Stay curious. Question everything. There is no single flat Earth model. Rather, there are several competing versions. The most common pictures the Earth as a disk with the North Pole at its center. Antarctica is not a continent, but an unbroken ice wall that prevents oceans from spilling into the void. The sun and moon are described as small, luminous disks moving in circles overhead, perhaps a few thousand kilometers away. Day and night result from these lights, moving in and out of view, like spotlights on a stage. Some proponents suggest a transparent dome or firmament covers the disk, with stars attached to it. Others incorporate religious cosmology, describing Earth as the center of God's creation. There are models with multiple suns, infinite lands beyond the ice wall, and even worlds stacked atop one another. The variety reflects a fundamental problem. Each model tries to account for observations while maintaining flatness, often at the expense of consistency. Yet the sheer creativity and conviction behind these models highlight how far people will go to preserve an alternative worldview. A cornerstone of many flat Earth models is the idea that the sun and moon are small and close. Advocates argue that the sun and moon are only a few dozen miles across and orbit above Earth at low altitudes. They explain day and night by comparing the sun to a spotlight, shining on one region while the rest is dark. To support this, they point to sunbeams radiating from clouds, suggesting the sun is nearby. However, the spotlight theory fails to explain why the sun appears the same size at sunrise and noon, why solar eclipses occur at predictable times, and why the moon casts a full Earth-sized shadow during a lunar eclipse. If the sun were local, its light would create sharp boundaries between day and night and would shrink or grow noticeably as it moved. Instead, sunrise and sunset are gradual, and the sun's angular diameter hardly changes. Conspiratorial minds might say perhaps unknown lenses refract light in ways we don't understand, but applying this reasoning consistently makes other observations impossible to reconcile. Flat earthers have a gravity problem, literally. In their universe, Newton and Einstein's gravity just doesn't work. So what keeps us grounded? Some believe heavy objects displace lighter air like a stone sinking in water. Others suggest magnetism or electricity holds us down. But the most popular theory, Earth accelerating upward at 9.8 meters per second squared. Here's the problem. Constant acceleration would push Earth toward light speed, which physics forbids. If acceleration slowed, our weight would change over time. Nobody observes that. Plus, heavy and light objects fall at the same rate, contradicting the heavier sinks faster idea. These alternative forces lack mathematical descriptions, making them unfalsifiable. The conspiracy twist: scientists supposedly invented gravity to hide Earth's flatness. But then why do their formulas accurately predict planetary motions and satellite orbits? Rejecting gravity demands a complete physics overhaul that flat Earth models simply don't provide. Flat Earth lore often portrays Antarctica as an endless ice wall ringed with guards, preventing anyone from approaching it. In reality, Antarctica is a continent about the size of the United States and Mexico combined, with mountain ranges, glaciers, and open coastline. International treaties reserve the continent for scientific research and environmental protection, but tourists and private expeditions visit each year. Flat earthers point to those treaties as evidence of a secret. Why else restrict land access? Yet the restrictions apply to military activity, mining, and environmental harm, not to tourism or exploration. In December 2024, a group of flat Earth influencers traveled to Antarctica to see for themselves. They witnessed the sun circling the horizon, never setting, a phenomenon predicted by a tilted sphere, but not by their map. Some admitted their model needed revision. Others suggested there must be unknown optical phenomena at play. This narrative tension between direct experience and community doctrine reveals the allure and fragility of conspiracy thinking. Stand at the ocean's edge, and the horizon looks perfectly flat. But here's the thing. Your eyes are lying to you. At sea level, that seemingly straight line where sky meets water appears to confirm what flat earthers claim. But Earth's curvature is incredibly subtle. Over just 1 mile, the planet drops only 8 inches. That's less than the height of a standard sheet of paper standing on end. Our human eyesight simply isn't sharp enough to detect such tiny changes across vast distances. When you see photographs from high altitudes showing Earth's curve, some skeptics cry fisheye lens. But even with distortion-corrected cameras and rectilinear lenses, that curve remains visible. Here's where it gets really interesting. Atmospheric conditions create mirages, and what scientists call superior mirages, where distant objects appear higher than they actually are, temporarily masking the planet's curvature. Those laser tests over canals that flat earthers love, temperature-layered air can bend light beams, giving misleading results. Proper experimental design has to account for these optical tricks. The truth is, it's remarkably easy to see exactly what you expect to see, especially when you're searching for hidden truths. But science requires us to look deeper than our first impressions. The Bedford Level experiment is a flat Earth touchstone. Samuel Rowbotham observed markers and claimed they remained level. Later, Alfred Russel Wallace used proper surveying tools and found curvature. Modern flat earthers use lasers across lakes, but when results show curvature, they blame equipment malfunction or mystery beams. Misinterpreted experiments spread quickly online, but scientific experiments must control for all variables.
Temperature gradients bend light. Water surfaces curve due to wind. Measurement tools have precision limits. A good conspiracy thrives on secrecy. In science, transparency is key. When amateur experiments claim to overturn centuries of physics, ask, were all factors considered?
The internet can connect people across the globe, but it can also trap them in echo chambers. Algorithms designed to maximize engagement prioritize content that elicits strong reactions. Conspiracies, like flat Earth theory, often produce high engagement because they propose hidden truths. Once someone watches a video questioning the globe, the platform recommends similar videos. Over time, a person's feed becomes saturated with content that reinforces a single viewpoint. Communities form in comment sections and private groups where members encourage each other and dismiss outsiders. When dissenting voices appear, they may be labeled as trolls or agents of the system. This environment fosters a sense of belonging and righteousness. Believers feel they're guardians of suppressed knowledge. Meanwhile, scientific explanations are dismissed as propaganda. Recognizing this dynamic helps us understand why flat Earth theories thrive online. Breaking out of the echo chamber requires curiosity, critical thinking, and exposure to diverse perspectives. Perhaps the most dramatic moment in flat Earth discourse came when some adherents traveled to Antarctica to test their beliefs. They expected to find an impassable wall or restricted zones, but instead found research stations, penguin colonies, and a sun that circled the sky without setting. One prominent flat earther spent tens of thousands of dollars to witness this and admitted publicly that he had been wrong about the sun. Rather than being lauded for his honesty, he was ridiculed by other believers, labeled a traitor. This reaction exposes the social cost of leaving a conspiracy community. For some, admitting error means losing friends, followers, and identity. The Antarctic trip underscores a truth about belief. Sometimes evidence isn't enough to change minds when community pressure and cognitive dissonance are at play. Yet such journeys also plant seeds of doubt that may sprout later, quietly undermining the conspiracy from within. Why do people cling to ideas that contradict overwhelming evidence? Cognitive dissonance plays a part. When presented with information that conflicts with deeply held beliefs, we experience discomfort and look for ways to resolve it, often by rejecting new information. Confirmation bias leads us to seek sources that support our views and ignore those that don't. Conspiracies can be comforting because they provide simple explanations for complex phenomena and give believers a sense of control. Being part of an in-the-know group offers social rewards. Many conspiracy believers mistrust institutions because of past experiences. Tackling such beliefs with mockery often backfires. People double down when attacked. To reach conspiracy believers, one must understand the emotions and identity tied to the belief. Empathy and patience can open dialogue where facts alone cannot. We're living in an age where conspiracy theories spread faster than scientific facts, and scientists are finally waking up to this reality. For too long, researchers stayed in their ivory towers, publishing papers that only other scientists could understand. But misinformation doesn't wait for peer review. So how are scientists fighting back? They're meeting skeptics where they are, online. They're creating YouTube videos showing exactly how to replicate experiments. They're partnering with social media influencers to explain complex concepts like gravity in plain language that actually makes sense. Universities are opening their doors with public science nights, bringing out telescopes, pendulums, and hands-on demonstrations. The goal isn't to shame people for their beliefs, but to model genuine curiosity and transparency. When scientists acknowledge their mistakes, admit uncertainty, and show they're human beings seeking truth, rather than elites dictating from above, people start listening. This isn't a quick fix. Rebuilding trust takes time. But consistent, respectful engagement is slowly eroding the allure of conspiracies. and that gives me hope for our future. We've traveled from ancient myths and shadow measurements to viral videos and Antarctic expeditions. We've seen how science builds a consistent, testable picture of a round Earth, and how flat Earth theories weave alternative narratives filled with intrigue. The persistence of flat Earth belief reflects deeper currents of mistrust, curiosity, and the human love of mystery. Whether you're convinced by the evidence or fascinated by the conspiracy, choosing between competing stories is up to each of us. If you enjoyed this deep dive, please like, comment, and subscribe. Next time, we're leaving Earth behind to explore our nearest neighbor. From strange lights to ringing like a bell, the moon is truly weird. Join us for The Moon, It's Weird. Don't forget to turn on notifications so you never miss a video.